All right, ladies and gentlemen, let's get to it. What I'm going to be writing in blue is kind of the shortcut notation is what I'm going to call it. It's what it would look like if I was working the problem a little bit more worked out because there's some things I would do in my head just because I've done it enough. And then the orange, it's what's actually happening kind of in the background. So let's start out with just rewriting the problem. All right, so I'm just going to explain what's happening. Then I'm going to go back and show you what it would have looked like if I was working it. First, we need to realize that there's two things that we are just learning how to do. There's something to the zero power. We should know what to do. And then there's something to a negative power. We should know what to do. In either case, we get 4 times 1 because anything, this was x to the 0. Anything to the first power is 1. And then what we're going to do here is we're actually, that's last lesson. What we're actually going to do is we're going to be taking 1 over y to the third because anything to a negative power, you need to invert or put over 1. All right, now that I've done that, I can work on trying to get it even more simplified by taking 4 times 1 and getting 4, and then getting 1 over y to the third. But it's still complicated. I'm dividing by a fraction, so I kind of want to get rid of that. So if I get rid of it, what it means is I have 4 over 1, all divided by 1 over y to the third. Now, here I should be able to notice that if I multiply by the reciprocal, it's the same thing as dividing by the fraction. So if I take 4 over 1 times y cubed over 1, that's going to be the same thing as 4 times y cubed over 1 times 1, which is 1. And anything over 1 is 4y cubed is just itself, okay? So again, what we did was we used our rule that anything to the 0 power is 1. We substitute, so we replaced that. We simplified it to say 1. Well, it originally read 4 times x to the 0, so that still says 4 times whatever x to the 0 is. 4 times 1, 1 times anything is itself. Check, got it. Then anything to a negative power is actually equal to 1 over that base to the same positive power. So I did that. Then I had to recognize that 4 divided by a fraction needs to be rewritten a little bit. So I remember that I need to turn the 4 into a fraction, so that's just 4 over 1. Then I need to divide that by the other fraction. And then in order to do that, it's multiplying by the reciprocal, which just means that I have 4 over 1 times y to the third over 1, because reciprocal is nothing more than a fancy word for flip. It's a good word. It's very specific. It's just we can generally say flip it. Now, that'll get me 4y to the third over 1. Anything to the over 1 is itself. So our final answer is this. Now, again, that's just going over every kind of detail that's in the background. Here's how I would have worked it to begin with. I probably would have just kept this for now and then brought that up. Because remember, my shortcut just says whatever's in the denominator goes to the numerator, what's in the numerator goes to the denominator. Well, the y to the cubed was in the denominator, and it was negative, so I could move it up to the numerator. And then I would have worried about that x to the 0, so I would have done, I don't even know how I did that. Let's get rid of that. I would have done in my head, x to the 0 goes to 1. So in my head, I actually wouldn't have even written all this. I would have just done it. I would have said 4 times 1. X to the 0 is 1. 1 times 4 is, and I would have just kept it. But then I have 4 times 1 is 4 times y cubed, and I'm done. So obviously, to me, I would be wanting to do the shortcut notation. And that's fine. But look at everything that's in orange that you have to understand what's going on to truly understand why you can just write it in blue. It takes everything in orange. I mean, that's a lot of what math is. We all want to do what's in blue. We want to do the shorter one, the one that looks easier. But it takes knowing everything that's in orange in order to do that. And how you would have done it might have looked a little bit different. And to me, that's kind of the beauty of math, is we all get to make it our own. We all get to make it individual as long as we all know what's in orange. We all have to know this. We can then start making our own shortcut notations. Okay? So that's why it's important that you learn the details. You pay attention to those details. And it's a lot. I get it. It's one of the reasons we teach math, is to make sure that we learn how to know a long process or apply a long process, or just be able to memorize and know and do a lot of information in the order it needs to be done.